So there are some facts about the parent functions that I just want to go over related to how they are behaving from left to right, whether they are increasing, decreasing, constant. We're going to talk about the extrema. Remember, extrema is just, do they have a maximum, minimum, a peak, a valley? And then we'll also talk about domain and range. So we're just going to kind of do this very quickly and just go over our parent functions. So remember, our constant function is y equals some number. Oh, go ahead. Okay, so, you know, whatever the number happens to be, so in this case, if our number is 4, you know, we would go like this. Okay. So there are no extrema. There are no bumps, hills, valleys in a constant function. The domain is all real numbers. The x's can be whatever they want to be. The range is only one value. It is the value that you're stuck at. So like 4 is our value. So the range, you can just put 4 in a bracket. I've seen it done like that. And I've seen it done where you kind of say, I started at 4, I ended at 4. It's 4. Okay. Now, because of the name, our little math bug is flat the whole entire time. So it is constant along its entire domain. So that's what we know about a horizontal line. There's no extrema. The domain is any number I want. The range is just one value, whatever height we are at. We consider this a constant function, hence why they gave it a name. Let's talk about the identity function. So remember, it cuts through it perfectly down the center. So it's our straight line with a slope of 1 going through the y-intercept. There's no extrema, no bumps in it. The domain is all real numbers. The range is all real numbers. Now, think about a sloping line. If the slope is positive, it's going to end up being an increasing function. If the slope is negative, it's going to end up being a decreasing function. So here our slope is 1. So the slope is 1 of this line. So it is increasing along its entire domain. So from an x value of negative infinity to positive infinity. Okay. In any linear function, just look at the slope. If the slope is positive, it's an increasing function. If the slope is negative, it's a decreasing function. That's one great thing about slope. And if the slope is 0, it's a constant function. If the slope is undefined, it's not a function. Okay, let's talk about the absolute value function. One of the things I noticed on some of your quizzes when you were making the absolute value function, it is a perfect V. So think about this line right here. That is half of that line. And it should be a perfect V here. Some of you tried to make it a little more closed like that. The parent absolute value function is going to be smack dab in the center. If the slope changes, like if it was the absolute value of 2x, it could be a little steeper than the original. But the original, please note, it goes through 0, 0, 1, 1, 2, 2, 3, 3, and so on. It goes right down the middle for both of those. Okay. Now, there is an extrema here. The 0.00 is an absolute minimum. Bless you. This function has 1/2 that is decreasing and 1/2 that is increasing. So this half here is decreasing. So that's from an x value of negative infinity to 0. And then this half is increasing from an x value of 0 to infinity. The domain is all real numbers, But the range, as long as it's our parent absolute value that's a V and not an upside down V, the range is from 0 to infinity. Lowest point is 0, highest point is whatever I want it to be. So that is the domain and range, and increasing, decreasing. Half of it is decreasing, half of it is increasing. And that's why our absolute value has that, it's a piecewise function. One piece is decreasing, that's our negative slope. One piece is increasing, that's our positive slope. So those are our first three of our parent functions. Now let's talk about our reciprocal function. Remember, that's y equals 1 over x, or y equals x to the negative 1 power. When you want to take the reciprocal or flip something, you use a negative power, so that can be a way to remember that that is the option. Flip it, 1 over x, or x to the negative 1 will do the same thing. Remember that this graph, there is a dashed line down both our x and our y axis. We never touch those. Most reciprocal functions will have that happen, that there will be a undefined x and an undefined y. And then it has kind of almost like a very rounded L shape. And I'm not great at making these, but the reason that this piece is here, because if you stick in a positive, you get a positive. The reason this piece is here, if you stick in a negative, you get a negative. So this is an odd function. It has this symmetry that if you spun it around the origin, it would look like you hadn't changed it. Now, this one's a little weirder, okay? So let's talk about domain and range first. Domain, I skip 0. So we write it like that when we skip something. Range, we skip 0. So we skip an x value of 0, we skip a y value of 0. That's what those asymptotes are kind of indicating. Now, the graph is in two pieces, so then you have to analyze, are both pieces going downhill or both pieces going uphill? So I kind of do them separately. So let's think our math bug here. This piece, you can see he's going downhill. Now, if our math bug is on this piece, guess what? He's still going downhill. So both of these pieces are decreasing. So our function is decreasing along its entire domain. From the first piece, that's this piece. Oop, it's going downhill. This piece also goes downhill. It's kind of interesting. It doesn't seem like it, but as we walk from left to right, you're always going downhill. There's no actual extrema for this one. There might be some that have a little more of a high point here and here, but it doesn't. These ones don't. Let's go with our quadratic next. Y equals x squared. Remember what it looks like. 1 squared is 1, but negative 1 squared is also 1. 2 squared is 4. 3 squared is 9. So if you wanted to be more accurate, you could plug in those points. The domain is all real numbers. Everything can be plugged into this. Nothing messes it up. But the range, the low point is 0 and the high point is infinity. Now, just like our absolute value function, if the math bug starts on the left and starts walking, one side's going downhill, one side's going uphill. And that's very common for a quadratic to happen. One side will be decreasing and one side will be increasing unless you flip it over, and then those things flip over. So this side of my graph, the math bug's going downhill. So from negative infinity to 0, it is a decreasing function. But as soon as we hit an x value of 0, our math bug would go uphill. So from 0 to infinity, it is increasing. This is one that does have an extrema. This point right here is an absolute minimum at 0, 0. Any parabola that's facing upward will always have an absolute min. If you flip your parabola over, it will have an absolute max. Let's see if I've forgotten anything. Increasing, decreasing, domain and range, and extrema. So that's your quadratic. Now remember, our cubic is y equals x cubed. Kind of what it is in the name. It looks very much like a very steep parabola on that side. And then just flip this one over. So, because negatives stay negative, they don't get positive. So that's why this piece goes down. So it's like half a parabola going up, half a parabola going down, kind of. Now, the domain of this is all real numbers. The range of this is all real numbers. The math bug, if he starts down here, he will go up forever and ever and ever. Cubic functions, the parent ones, the simple ones, are either always increasing or always decreasing. So for an x value of negative infinity to positive infinity, the y's are increasing. There are no extrema here. As long as it's just an x cubed and not like an x cubed plus 2x squared plus 3x plus 7, those extra terms can make bumps in the graph and it might have extrema. But ones like this, there's no peaks or valleys. There is this little point here. See where the curvature changes? That point in calculus, that 0, does mean something. It's called something called a point of inflection, but you don't explore that until you get to a calculus class. So those are those three. Does anybody have any questions about those ones so far? Okay, we're almost, yes. Increasing. Sorry, my handwriting there. Sorry. Okay, so those, any other questions about those ones? Okay, so now let's go to our last ones here. Now, our reciprocal was that 1 over x. Our reciprocal squared, just square what you saw in the first one. So it's 1 over x squared, or x to the negative 2. To get that x squared in our denominator, you need a negative exponent, and that will flip it down. Now let's think for just a moment about squaring a negative number. When we square a negative number, what happens to it? It becomes a positive number, right? So still has these, but the difference now is that the positive piece stays positive. Square positive, it's going to be positive. But now the negative piece flips. But it looks very similar to our, look at this one right above it. They're related completely, except when we square a negative, it doesn't go negative, it becomes a positive. Okay. So the domain is still every number but 0. So we go from negative infinity to 0, skip across it, because there is that asymptote down the middle. Okay. The range is weird here. Think about, I can't stand at 0, but I can stand at every value above 0. So that's how you have to write your range. Your range goes from 0, don't include it. I can keep going up and up and up forever and ever and ever. There are no extrema, just like our regular reciprocal function. But let's talk about the math bug. We flipped over a piece. If you look back at the reciprocal function, it was decreasing when the bug walked across both pieces. But now look at this piece. This piece goes uphill. That's an increasing piece. This piece goes downhill. So this piece from negative infinity to 0 is increasing. Our bug is going to go uphill. This piece from 0 to infinity goes downhill, so that piece is decreasing. So there's our reciprocal squared. So that squared has changed one of our pieces. The extrema, or I'm sorry, the increasing, decreasing, and the other one are a little different now. Got two more to talk about, and then you'll have the rest of the period to work on homework or whatever, Alex, or whatever you need to. Any questions about that one? Okay. So remember our square root function, y equals the square root of x. Or you can also write it as a 1/2 power. Fractional powers indicate that we have a type of radical or a root of some sort. So the 2 indicates a square root. It looks something like this. Think about perfect squares. 0, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So I used 4, 2, and 9, 3 to be more accurate. Do you have to be more accurate? Not necessarily, but that's how I did it. Okay. The domain are the positives, remember? So it's from 0 to infinity. The range, the lowest value is 0, but I can go up as high as I want. This eventually keeps getting higher and higher. It takes a while because that square root keeps kind of smushing it a little bit. There are no extrema. Sometimes some books will call this an absolute minimum, but it depends upon the book. Sometimes they do, sometimes they'll say it's an absolute minimum. Sometimes they won't. It's not an extrema like we normally think of an extrema. Increasing or decreasing. Our little math bug, if he starts over here, he's always going to be going uphill. And so it is increasing from an x value of 0 to infinity. Increasing and decreasing, don't use brackets most of the time. Just use your parentheses because the endpoints or any switchovers we usually don't include. Okay. Last one, cube root. Now remember, the cube root just has that little index here of 3. That's why the fraction changes to a 3. That indicates a fractional exponent, indicates a type of radical. So our denominator is a 3, that's a cube root. If our denominator is a 4, it's a 4th root. If our denominator is a 5, it's a 5th root. Because we can plug in negatives, we actually have a similar piece down in the negative section. Some of you forgot that piece for the cube root. Negatives are okay. I can plug the negative, or the cubed root of -1 is -1. The cubed root of -8 is -2. The cubed root of -27 is -3. So it is allowed, it's perfectly okay. Just like our cube function, the math bug, once he starts, although he gets a weird spot right there, he is still going uphill forever and ever and ever. So it is increasing from an x value of -infinity to +infinity, which is the domain. So the entire domain, he's going uphill. Even though it's going to take a long, long time, this keeps getting higher, higher, higher. This keeps getting lower, lower, lower. So it eventually will go to a range of -infinity to +infinity. It just is going to take a while to get that high. Like, think about to take the cube root of some number and get even 100 is a million. The cube root of a million is 100. So, it takes a long time for it to get higher and higher, but it does eventually. There are no extrema. If you mess with the inside, you could possibly get some extrema, but for our purposes, you don't have any. So that is just, really thinking about everything we've learned so far about functions in one place. So, increasing, decreasing, constant, domain, and range, extrema, those all can be applied to any type of function. Our parent functions, it's very important that you kind of contemplate what's happening with the parent functions. so that you can then understand once we get to more complicated polynomials in the future. Okay, so you should have your notes finished. So if they are finished, please turn them in at this time. If you were absent at all, just mark that you were absent on the note sheet, and then just take a screenshot of this page, and that's where you turn in the parent function facts, I think it might say. And then I think everything's marked to be turned in tomorrow, except for Alex. No, no. You don't have to memorize this one. This page is just for us to start thinking about those things. I might eventually give you one of those on a test and say, tell me what's happening. Where is it increasing? Where is it decreasing? But I wouldn't have you tell me all of that stuff. Yeah. Anything else? Okay, so go ahead and work on your own stuff for the rest of class.